Hello Earth, welcome to episode 39 of season 3 of Making Cell. Making Cell is a series of videos where I record myself designing and implementing a programming environment called Cell. If you're just tuning in for the first time, I recommend you go check out github.com/autocodenl/cell. I'm pasting now the link in the description. So, where were we? I was actually writing some ideas and I realized there's no point because I had ideas away from computer, let's say. So I wanted to write them down and figure I might as well just turn on the camera and write them together with you while being recorded, and then that might make a difference in the ideas. They might actually come out better. So I was basically grappling with whether the language would be usable or not, because I have a lot of I wouldn't call it nice theory. I have, I think, solid concepts and already an implementation, but the main point of uncertainty I have right now is this really going to work in practice? Like, is this going to be an expressive language in practice? So I was working on that problem, and I came up with a few ideas. So where can I start? So first of all, instead of add do, I want to write add s. S stands for sequence, and we're going to have it everywhere, so it makes sense for it to be short. Perhaps it could also be add seq. But I want you to consider this possibility, this scheme that I was having in mind. So add is just, it will be reference. So add is the reference, so it has 1 of length. And then you can have, it would be at s, sorry, it would be at s is sequence, so it's 2. Characters, let's say, without counting the space. And then you have at if is conditional. Which is 3. And I have add put, which is storage. Storage is key, and I actually want to update the treatise that I wrote last year to be more explicit about this, because even a Turing machine needs a way to store things, to write in the tape, and also get those programs in somehow. And then we have loop, which is iteration. Now we have catch for errors. And I forgot to say, actually this is 0, not 1. 1, 2, 3. And I honestly think this is quite memorable. The main calls ordered by length. So I just want to run this through the LLM to see if I get an interesting idea from there. Why add S for sequence? So we can try it and see how it feels in the end. Because LLMs, they have a tendency to be quite willing to agree with what you say to them. So I have to be careful with that. I have to be careful with that, at least with that. So what problems was what I was dealing with? I'm just looking at this paper I wrote in pencil a couple of days ago. Idea is a shorthand for puts. For example, put foo3. Basically, if there's no v, you assume that's v. This could work. I need to put it in a to-do. I need a to-do somewhere that is one to-do one instead of 4 things. Did I not have one of this? No, because it's split. This one, I think we have tests for this, so we don't need this anymore. Actually, I think I need to be organized and then just do it. But this is the features, right? It's just put with without v. Just assume it is v. Okay, so that's an idea. I'll just put it there. And then what else? Something to remember, all the logic is in the colon, that is in the expansion. So I will let you know in a minute why I was taking so long to do this. I'm writing down all the easy things. Cell has is all prefix, unlike fourth like. The call always comes first. Ideas for HTML generation. Not all are new. Everything is each tag, each element is a hash. The children go in and can be either another element or a list. Use CL shorthand for class and allow to pass a list of texts. This is going to be mighty useful. For example, div id and then here you have the children. Oh, that's just beautiful. And then you could have the on click like actually you can just pass a sequence here. So this is frozen. Notice how you can pass a sequence to a handler and freezes it. This one already there. This is the stuff I was doing. So special because it pretends. What did I want to say here? Prepends every call with an add. Yeah, observations. I was also watching a video about TCL a couple of days ago. TCL. In TCL, everything's a string, but there are brackets actually. So just some observations there. This one for Todis, I'll probably do it at some other moment. But now I want to get to the, well, one more thing. Structure of cell. Would be something like this. What? Editor. This is the language and engine are essentially in the same place and have a soft boundary. Softer is the service. So this is how I'm thinking it. Yep. Okay, now onto the so I was struggling with this. Let's just define this function called fizzbus, right? This is in the language in action. So fizzbus is basically if receives a number if divisible by 3 and not by 5, returns this. And we do it all around. This is divisible by 3 and 5, returns this bus. So let's just define this. So it takes a number, and what I want to do is the following. I want to start by, I want to be able to know how to initialize variables, and because that's basically shorter and it's going to save us a lot of work, and you can still have a good convention. So hear me out. If the condition, I'm starting to lean towards short variable names in the stuff we use all the time. If the condition is that it will be this, if it's divisible by 3, and look at how I'm passing them in line, so I'm assuming it's possible to do it, but I think it should be possible, and I'm referencing n here. I will do an else here. Because that's one way to do it, but maybe I can just do it like this. If not, or I could just be more explicit. If it's equal because it's divisible by 0. Now let's just make it short. Let's make it like someone who's proficient in this. So if I don't need this. Sorry, yes, of course I need this. I will be, the condition is this, else, no, it's too short. I have to do it like this, otherwise it's just indecipherable. The condition else, I will do, I need to basically append or push or stick, right? Yeah, I need that function. But in this case, it's the first one, so I can just do put just put a single path. This would be very followable, I think. Put, let's call it output as this, right? Then I want the push just to have symmetry between both. We can do it like this. So, and then we'll just do it like this. And then I just do output here, and that's where we're going. So that's the definition of FizzBuzz. Let's get some feedback. This is succinct enough for me. I could totally live with this. So let's look at the execution. What do I mean no put inside? Ah, yeah. Yeah, but in this case with the push, for example, I don't know which is which, right? So I have to do it. Yeah. Divisible by x means that returns 0, which is falsy. Perhaps it's a bit tricky, but it should be the case, right? It's taking a merry time, so let's just do the execution. And sorry, this is completely wrong. It's like this. There. Yeah. So let's just do fis bus. What? I don't know. 4. So the result is going to be empty text. The call what am I doing? The result is here. And now for the expansion, right? An interesting idea is to not use the colon and just use S to show the sequence. It will be S. The two problems I'm having have a place for intermediate values, including the message, and which has to be a hash, and then having the sequence, which is a list. Maybe we can do colon S and put the sequence there. So let's just do that. So we could do something like this. We could have we would have n is 4, sequence is would be 1. This would be this if doesn't return anything, and the add is if. It's a bit trickier to expand. How would it look? So this is going to be 3. And this one is going to be 4. At n, what did I do? and this one stays frozen. Push B, output B, nothing happens here. And there's no expansion really in these ones. There's just no column there in the middle. So this one would be a 2. It would be pretty much all the same, right here. Sorry, it would be 1, not 3. What am I doing? And if I do it by 5, then it would be 4. This is 5, and this would be bus, and nothing happens. And then 3 would be equal to this. The risk here, ooh la la, I need to be able to do this. We need dots on near references to avoid going up, either that or initialize the variable. I wonder if I need that. But here you still have to walk up once, right? I wonder if I need that dot. Maybe I shouldn't do the dots. Maybe dots are mistakes. Maybe we need to initialize things explicitly to know where they hang in the tree. Everything is too dynamic. Is this speed bump going to become annoying? But what are the alternatives? I'm dancing with destiny here. Because technically speaking, this output, you would search inside the if, really. Yeah. So it's honestly, it's bullshit, that dot. I would have to have like a maybe the dot is absolute bullshit, because I was also thinking of doing 2 dots to go 2 levels up, but no. My gut is telling me to initialize, although I don't like initialization. Redis doesn't have initialization, but Redis has a flat key space, and here we do not have a flat key space. Maybe we need to get rid of the dots completely. If I look at the texts, we only have those. What I need is, okay, I wasn't expecting this, huh? No. What we need is not dots. What we need is one to initialize explicitly to be able to go more than one app with an operator. For example, app but let's add that one when we need it. So let's do this without dots. I would basically do put here. The dot in the put, yes, you need is to say do it here if it's not there. Honestly, you could do it like this. Also put without v. Assume it is. This is for initialization. I have to say Mr. Ginger Root is really doing great here. Very, very well. So we have this. Oh wait, did I not close it there? Oh yeah, I did. Wait, no. Bam, 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 bam. So I just initialize the output there. Beautiful. I can just do it like this to be slick. I don't need a dot here. I almost wrote an equal there. Hehe. The problem with S is that it's kind of in the middle of the whole thing, but maybe we can tolerate that for now and maybe fix it with sorting. No, we probably need to apply a sorting to it. So one is can just put, instead of doing okay, I'm thinking of, and always return the old value and the new value. If the old value was nothing, not even an empty text, just return one value. Just one value? No, because it could be ambiguous with some lists. Return a list with one item. So we have a div. That's useful. You see on every put what happens. Seeing a div on every put really tells you what happened. Or instead of a list, you can do it like or better, from and to. No to if. No, let's just go with the. Oh, sorry. So I'm putting this thing. Nice. And here I don't need the dots at all. So now let's add one more. Wow, this is beautiful. So if I do 15, that's a fun case. I'm gonna get this bus. The output. I don't need the quote, silly. The output is gonna be this bus. And the first step is always the same. Oh wait, how am I knowing that? Well, yes, in this case, why is it not setting it here? Because it goes, I guess, in this prefix. No, it would go on S1, so it wouldn't work. Okay. Wait. Dot doesn't work. Rather, put with dot, because we need to do it at one up. If you are inside S1, putting something here means in S1, whereas we want to do it outside those two. In colon. Wait, we could write put p colon output. Of course. Why the hell not? You go find colon. Yes, that's the elegant solution. Elegant solution. No need for a dot. But wait. It will try to find colon output and won't find it on initialization, right? And then I would say I'm having fun. I'm not doing this for fun, but I'm having fun. I'm grateful for that. So let's just go back to this song. Mr. Gingerroot. So it will walk all the way up and then finally set colon output there. Not so cool. And if I do P colon and V output 30, then I'm also overwriting everything. Not good. I'm thinking, huh? Of course, I don't want to hard code things in the sequence that you go one up or two up. Like, no, I want to make it really self-similar and simple. Because it's the key. It's always been the key. Does it make sense for it to walk up in a put? Yeah, why not? Yeah, of course it makes sense. Don't be silly. The path is more than one. No, only the first silliness. Yeah, but it's not so easy not to be silly, yeah? So, I think I almost have it. I need to tell you this. I need a put that doesn't overwrite. I need to put it at colon output. Wait, how does it work, the walking up with the puts? No, it should work. Should work. Find the colon, then find something else. But that something else wouldn't be there. How does it work? Ta-da. Yeah, matching the whole thing, right? Mm-hmm. Yeah. We're going to find the context path for which we get a match on the left side. If context path is empty, no, because we're pinning the context path. That's how it works. I would need like a relative context, right? Something like that. It's a bit tricky to say all of these things. What is a simple solution? It's like it's almost here. Solutions. Make the colon path be special inside a sequence. Org. Pass a context path to put. Do a put that upserts instead of overwriting. Change the logic so that the first, the sequence again, element of P is first found. If that is found, then the rest consider to, then you found your anchor. this is not like get, where you walk up on the whole path. This is a difficult problem. What would be beautiful is to be able to just write. Because let's go for a bit with that walking up logic that only uses the first element of the path to find an anchor. Then it would work only if that call didn't have its own expansion. If it did, it would be snagged. Yet another option is to somehow initialize output, but that violates the principle of the sequence doing its thing. No, it has to be solved here. I feel like there's like 7 ways to do this, and perhaps only one that is correct. It'd be silly to have to say up already in a standard case like this. You want your expansion to have these top level variables of the expansion. I wonder what is the if there's a single proper mechanism for walking up, both for put and get. Is it whole path or leading step? Leading step, as it's virtuous. You follow just comparison instead of having to look at the entire tree to see if there's a match. But this is pure only the first silliness. My question is, does it still make sense? I need more test cases. Yeah. Yeah. I think you notice I didn't write any more tests for now because instead of writing tests, I want to make sure that the language makes sense. I already am very confident in the parsing, and the tests are good for detecting corner cases, but the logic has to really make sense. I think I will think of more problems. I think I need more design. Okay, I think I'm gonna stop here. Thank you for watching.